Dear friends, how are you all? I hope you are well and great in this pandemic world. I am very good in your prayers and love. I am going to discuss the matter with you today. I hope you will like it very much. I hope that the main topic of today's discussion is dasymetric mapping. If you are curious, take a good look at the whole video. So let's get started. First of all, I want to give a basic idea about dasymetric map. Dasymetric map is a type of thematic map that uses aerial symbols to visualize a geographic field by refining a Choropleth map with ancillary information about the distribution of the variable. The name refers to the fact that the most common variable mapped using this technique has generally been population density. Dasymetric maps are used instead of Choropleth map because they represent underlying data distribution more accurately. Choropleth maps and dasymetric maps differ in three main ways. Firstly, dasymetric zones are generated using ancillary data, while boundaries on Choropleth maps use unit used for more general purpose. Secondly, Choropleth zones have varying levels of internal homogeneity, while dasymetric maps are designed to be internal homogeneous. And the last one is, Choropleth mapping methods are standardized, while dasymetric methods are under-researched. Now, I want to tell you the advantage of dasymetric mapping. In contrast to Choropleth maps, dasymetric maps allow a more precise representation of areas of the same density. There is no risk that more dense and less dense areas cancel each other out and areas with a high density are no longer visible. Now, we can use a dasymetric mapping technique in Arcgis to create a population density distribution map. So if you want, you can follow my instruction in this video. Open ArcMap interface, then go to catalog, then connect your folder, then drag and drop your shapefile. This is land use land cover shapefile. This is the shapefile for population. Okay, I am changing the symbol selector. Now I am going to Dhaka LUL shapefile. Right click on properties, then go to symbology, then click on categories, then click on add all values. Then click on properties for selected symbols. I am giving the outline with 0 here. Then apply and OK. So now I am adding a relative density value to attribute table. This is my relative density weighted value of population. So this data will be added in attribute table. So right click on Dhaka LUL shapefile, go to open attribute table. Create a field here. Okay. For administrative land cover, the relative weighted value is 7. So I am giving here a value of 7. So for this I have to edit this one. Go to here, then start editing. Now I will put the value, numeric value here. For commercial it is 10. Then for educational it is 5, manufacturing for 10, mixed for 15. So educational for 5, 10, then 10, then 15, for 32, 15 2, for 32, then 15, 15, then 2. Save it and stop it. Here, what is the meaning of array? Array means relative weighted parameters. So relative weighted parameter means 7% population is live in administrative area out of 100%. Here commercial area, 10% people live in commercial area out of 100%. In educational land cover, 5% population is live in out of 100%. Also in manufacturing area, 10% population live in out of 100%. In mixed area, 15% population live in out of 100%. And others area, 4% population live in 100%. In residential area, 32% people live in out of 100%. In restricted area, 15% people live in out of 100%. And the service related area, 2% population live in out of 100%. Here, if you sum the all relative value, then we will get 100%. Alright, now go to population shapefile and open a table, and you have seen that here this is the idea of area, and this is the actual population, and under this location this is the area of square kilometer. So first of all we have to convert this vector file to raster file for getting the actual population in pixel file. So for this one, go to catalog menu, then go to toolboxes, click on system toolboxes, then click on conversion tools, click on to raster. After that click on future to raster. Input feature here, population shapefile. So click on DCC ID, then go to your desired folder where you want to save this file. I want to save my files on my Dasymetric Mapping folder and give a name as DCC ID or mean raster, and save. Now I want to change the spatial resolution in output cell size. So in my question, the spatial resolution of the output will be 20 meter by 20 meter. So I am giving here 20 meter instead of 49.09. Then click on OK. Alright, the feature has to be converted from vector to raster, and the layer has been added here. Okay, now go to catalog menu again, click on feature to raster, then click on input feature and insert population, and click on field menu and select actual population. Save the file on your desired folder as a name of population raster, then click on save. Now I am changing the output cell size. Here the spatial resolution of the output will 20 meters, so I am changing my output cell size as 20 meter instead of 49.09, and click on OK. The process is going on here, over here. Okay, the process has been completed over here, and the layer has been added on here. This is the raster file of population. Here, one important thing you have to remember that the overall population value has counted in each cell. The value is same in everywhere. If you sum this value, you will get a more value. That is not realistic. Alright, now we are working Dhaka LULC shapefile. So go to again catalog menu, click on feature to raster, input feature as a Dhaka LULC, then add and cover here and give the value in output cell is 20. Change the location directory where you want to save your file, then save and click on OK. The process is ongoing over here. Okay, land cover area has converted from shapefile to raster images. Again go to catalog menu, click on feature to raster, then input feature as a Dhaka LULC, click on relative weighted parameter, save the file on your desired folder as a name of relative weight. You can try to give the short name in here, otherwise it may be failed. Click on save and change the output cell size as per your question. Here I am giving 20 and click on OK. The process is going over here. Okay, relative weighted raster file has been added over here. Now I am changing the name for my better understanding in future. Raster, then this is also raster file. I am changing the name here for my future understanding. Okay, this is my relative weighted perimeter. That's mean if I click here, now I am checking here the pixel value is 4. That's mean here 4 people has living in this place. This value is 5. Here 5 people live in this place. Then click on here. That's mean Here 4 people live in this place. Now I want to create a table where I can calculate expected population and proportional population for each land cover type. So for this one, go to catalog menu again, then go to spatial analyze tools, then click on journal. After that, click on tabulate area, input raster as a DCCID raster, then input field as a DCCID. Here input LLC raster, then in field land cover. Save the file on your desired folder as a name land cover, tabulated area. Click on save, then click on OK. The process is going on. The process has been completed over here and the layer has been added here. Go to LC tab and open this one, and you have checked that under DNCC1 word the administrative value is 0. That means here the population quantity is 0. No population live in this area. Also you can see that in DNCC 17 commercial value is 0. That means no population has been living in this area. Also in educational field you can see that here 0. So no population has been living in this area. Here you can see that in restricted area for DNCC 1 the value is 0. So we have understood that no population has been living in this area. Now I will add a field over here as a name of total. Give it a long integer total. Okay. Right click on over here and click on field calculator. Click on yes. So double click on administrative plus commercial plus educational plus manufacturing plus mixed plus others plus residential plus restricted plus service related. Okay, and click on OK. So cumulative tip value of population has been added in total field. Now we will add the field of proportion in this table. So click on add field, give a name over here as a p underscore admin, then change the type here as a double, then click on OK. After that commercial, click on add field, then proportion underscore commercial, type as a double, OK. Then educational, add field, type as double, p underscore education, then click on OK. Then manufacturing, p underscore manufacture, then change the type as a double, OK. Then mixed, add field, proportion underscore mixed, change the type as a double and click on OK. After that others, add field, p underscore others, double and OK. Then residential, So click on add field and create a field as a name of p underscore residential, and census type as a double, and click on OK. After that, click again add field as a name of p underscore restricted, then census type as a double, click on OK. Then service related, proportion underscore service related, then the type as double, and click on OK. Now go to proportion admin field and right click on here and click on field calculator. Okay, clear. Then click on administrative, then divide by total, and OK. So proportion has calculated for each particular area or particular worded as a admin. Now go to proportion for commercial, click here and field calculator, then commercial divided by total, and click on OK. This is the proportional value for commercial for each word or each area. Same here. This is for education. Just I'm changing the field from commercial to education, and OK. This is manufacturer. Okay. Then proportion for mixed. Okay. Proportion for other. Sorry. Yes. Okay. Then proportion value for residential area, change it from others to residential, and click on OK. And the proportion for restricted area, change the value from residential to restricted, and click on OK. Now proportion for service related, and click on OK. Now I want to calculate the expected value over here. So now I want to create a field. Click on here, add field, and give a name as a expected classical pop, then type as a double, and OK. And go to here as in expected population field and right click on here, then go to field calculator, click on yes, and then change it, first bracket start, then click on proportion of admin, multiple by the relative density weighted perimeter of administrative area. This is 7, so go to here, then 7, first bracket close, plus, then first bracket start, proportion of commercial multiple by relative value of commercial 10, then plus proportion of education multiple by the relative value of education 5, then plus proportion of manufacturer multiplied by the value of relative manufacturing is 10, and plus proportion of mixed multiplied by the relative value of mixed is 15, plus proportion of others multiplied by the relative value of others is 4, plus proportion of residential multiplied by the relative value of residential is 32, plus then the last one is proportion of surface area multiplied by the proportion, the relative value is 2, and click on OK. We have seen that the expected population is 26%. So 20 by 20, that's been 40 square meter area. The expected population is 26%. Okay, now I am joining this table with population shapefile against DCC ID. This is the table field, DCC ID. Now I am checking this one, open a table, and this one is also DCC ID. Okay, now right click on here, join and relates, join. Okay, DCC ID. This is DCC ID. Then click on keep all records, then OK. Yes. Now go to here and click on open a table, and you have been seen that all tabular field has been added over here. Now I want to create raster image from this shapefile. So for this one, go to catalog menu again, then click on feature to raster from conversion tools. Click on here, input Dhaka population map for 19.2, then go to the field of total, then save your file on your desired folder. I am giving here the name total, then click on save, change that process size 20 instead of 49, then click on OK. The process is going on over here. Okay, the total population has been converted from shapefile to raster images. Okay, this is the raster images for total population. So I want to create a expected raster image from this shapefile. So check this one and check this one. Okay, so go to again catalog menu, click on feature to raster, then input feature as Dhaka 92 population, change the field as a name of expected population, save the file on your desired folder and give the name whatever you want. So I am giving here the name of expected, click on save, then change the output cell size 20 instead of 49.01 and click on OK. Okay, this is my expected raster image we just converted from this shapefile. Now I am changing the color ramp from here. Okay, now I am uncheck this one. Now finally I am going to create a Dasymetric map from raster image. So go to catalog menu, then go to special analyze tools, then click on map algebra, click on raster calculator, then relative weight of raster multiple by population raster is multiple by cell size 20 meter into 20 meter, then bracket close is divided by expected population of raster file here, then multiple by the total value of population, and save the file on your digit folder. Now I am giving her the name of Dasymetric map underscore population and save it over here and click on OK. The process is going on. Okay, now you have been see that the Dasymetric map has been created over here. Now I am changing the color ramp for my better looking. Okay, okay, I have selected this one, then click on apply, then okay. So now we can check what is the difference between Dasymetric map and the traditional mapping. So for this, go to layout view, then so I am creating a data frame for traditional mapping. Click on insert, then click on data frame. After that, go to Dhaka population shapefile, copy it and paste to here. Check this out. Okay. Go to properties, then click on symbology, then click on quantities for graduate color maps and change the value over here as a actual population is normalized by area of square kilometer and click on apply. Okay, now I am giving the name. This one is Dasymetric. Okay, traditional mapping. Okay, now you can see that in traditional mapping, in whole area the total population is 1,83,298 person. So you cannot identify the actual person in whole area. Whole area represent the total population, the total number of population over here. But in Dasymetric mapping, you can identify the each person in each location. So click on here, you can see that here the pixel value is 1.958. That means 2% live in this area. You can click here 15.6. That means 16 people living in this area. Now I am going to another places for checking. Okay, here we can see that the total population live in this place is 33,613 people. But in Dasymetric map, we will observe that only 15 people live in these places, and here 37 people live in these places. In this location, 55% live in these places. So friends, I think you understand what is the difference between the Dasymetric mapping and the traditional mapping. Alright friends, thank you for watching today's video. If you like it, just hit the like button and subscribe my channel.